Rearranging equations. The area of a trapezium is given by half the sum of the parallel sides multiplied by the distance between the parallel sides, which can be summarized here in this equation. We want to find the area when the parallel sides are of length 10 centimeters and 8 centimeters and the distance between them is 6 centimeters. So we're trying to find the area, and we just need to substitute into the formula. So in this case, the parallel sides are 10 and 8, so we can say 10 add 8, and the distance between them is h, so we'll multiply that by 6. So 10 add 8 is 18, half of that is 9, 9 times 6 is 54 centimeters squared. Find the height of the trapezium when the parallel sides are of length 14 centimeters and 8 centimeters and the area is 66 centimeters squared. So this time we know capital A. It's 66. We know the parallel sides of 14 and 8, and we're trying to find the height. So 66 is half of 14 plus 8. So 14 and 8 is 22, half of that is 11. And then 66 is 11h, tells us that h must be 6 centimeters. 6 times 11 is 66. We now want to rearrange the formula to make h the subject. Now there's more than one way of doing this, but the sort of thing that we must avoid is a fraction with a fraction in either the numerator or the denominator. So if we start with a is a half, a plus b h, what I'm saying here is we want h to be the subject. H is multiplying by all of this, so you could go for something like a over half a plus b, but that would have a fraction in the denominator, so that's not the best way to do it. The best way to do it here would be to multiply both sides by 2. Then a plus b, all in a bracket there, is multiplying the h, so divide both sides by that, and then you get 2a over a plus b. And of course you could have got to that same expression from what I've got here, but this would be the best rearrangement of this formula. Now, of course, a test for our rearrangement is, do we get this same answer with the information here? So, the area is 66, so 2a, so we've got 2 times 66, divided by a plus b, 14 and 8 is 22. 22 and 66 cancels down to 3 over 1. 2 times 3 is 6 over 1, which would be 6. So our rearrangement must be correct. Rearrange the following equations to make the indicated letter the subject. Now the more complicated these get, the more likely it is that there's more than one way of doing it. Now I can't go through all of the different ways. So we want to get y out of here. Now I would be tempted to expand this bracket and get xy minus xz is equal to 2. Now I want y on its own, so anything that doesn't contain y I'm going to move to the other side. So xy is going to be 2 plus xz, and now all I need to do is divide both sides by x, and I've got y on its own. like so. Here we want to get h, and it's a very similar type of problem, so let's expand the bracket. Now the first thing I'm going to do though is write it the other way around. So put the left over on the right and the right hand side over on the left. So if we expand out, we get a half bh plus b is equal to a. Now the b I don't want on this side, so let's take it over there. So a half bh is a minus b. Now, I don't really want fractions left in this if I can help it, so I'm going to multiply both sides by 2. So bh is going to be, now all of this needs to be multiplied by 2, and a good way of doing that is to put the a minus b in a bracket, or of course you could say 2a minus 2b, that would be absolutely fine. Now it's the h we want, the b is multiplying the h, do the opposite, divide both sides by b, and we get 2a minus b over b. Finally, we want x from this, so I'm going to say that t plus the square root of x minus t is equal to s. So I'm going to bring the t over to this side, so root of x minus t is s minus t. To get rid of the square root, I need to square. So squaring both sides, x minus t is s minus t all squared. And then we can bring this t over, and we get s minus t all squared add t. Now some of these can get quite difficult, but it's just a case of being systematic. So here we have r squared is L, p minus r all squared, and we want p. So L p minus r all squared is equal to r squared. Now the first thing I'm going to do is take the L to the other side, so dividing both sides by L. Now we want to get rid of the squared here. Now if p minus r all squared is equal to this, then p minus r must be plus or minus the square root of r squared over L. Now bring the r to the other side, so that's adding r to both sides, and we get r plus or minus the square root of r squared over L. Now we could leave it there, but there's something else we can do. We know that this is the square root of r squared over the square root of L, and of course the square root of r squared is just r. So we could say that's r plus or minus r over root L. Now perhaps the most difficult examples are where the letter we're trying to get, in this case x, appears in more than one place. Now we have fractions here. We can get rid of those fractions by multiplying both sides by a plus b. Some people refer to this as cross-multiplying. If we multiply this side by this, the a's will cancel, and we end up with x multiplying a plus b. If you multiply the right-hand side by this, the a plus b's cancel, and we end up with a x plus b, like so. The reason it's called cross-multiplying is if we look, the a's gone up and multiplied here, the a plus b's gone up and multiplied over here. Expanding here, we get ax plus bx. Over here, we get ax plus AB. Now if we subtract AX from both sides, that just leaves us with BX is equal to AB. Then divide both sides by B and we just get X is equal to A. So that one actually came out fairly simply. Now we want to find capital H in this one. So multiplying both sides by H plus H gives us T. H plus H is equal to 2HH. Expanding the bracket, we get T capital H plus T small h is 2HH. Now we're trying to get capital H, so we only want terms that have capital H on one side of the equation. Now I'm just going to rewrite this one as 2HH is T capital H plus T small h, like so. And then I'm going to subtract T capital H from both sides. So 2HH minus T capital H is equal to T small h. Now we want big H on its own, capital H on its own, so we could factorize here. And that would give us 2H minus T is equal to TH. Now remember, this is H multiplied by this bracket. Do the opposite. Divide both sides by the bracket. And we end up with TH over 2H minus T.